Okay, my name is Campesi. I want to talk to you all about Infinity's new variable compression engine. Kind of relates to what Vicky was talking about 2 weeks ago or last week, whenever it was, about Mazda's compression ignition engine. It's kind of like their only competitor right now with what's new in internal combustion engines. So basically, this is like what you have now, basic engine cutaway. And this is the crankshaft. So basically on this circle right here, imagine this goes all the way around, that's like the center of the shaft and everything spins around that. So whenever this connecting rod to your piston spins around this circle, this connecting rod will go like this, right? So then the piston goes up and down. What Infinity did is they added another link. So this link right here basically takes away the connection between that connecting rod and your crankshaft. With that, they can now add another connecting rod to this electronic actuator and change that angle. So between here and here, you see that's a different angle. That then allows that piston to go either further up or not that far in the cylinder itself. That can change the compression ratio from up to 14:1 to 8:1. And what that does is basically make it to where if you have a high compression ratio, you don't need a lot of fuel to get the amount of power you need. And when you have a low compression ratio, you can add a lot of boost from your turbo, and that'll give you the horsepower you want whenever you do want to add a lot of fuel to it. So this electronic actuator actually acts as whenever you're in the car, let's say you're going on the highway and you're cruising, you're in efficiency mode, and you step on the gas, the engine automatically knows that you want to add more fuel. This drops this angle down, and then the piston now can only travel 6 millimeters less than top dead center. So then your compression ratio go down, your turbo kicks in, and you get more horsepower. So this is actually like a legit picture of the cutaway. And one thing you notice is the amount of space that you have here now. Instead of, used to be your crankcase ended about here. So now that you have all that space, that's a lot more hardware in there, there's a lot more weight. Infinity did say they added about 35 pounds to the engine. So they make these in only a 4-cylinder right now. And in 2019, I think is when they're gonna first come out. But this actually reduces the friction in your cylinder with your piston. So the linkage makes that connecting rod go straight up and down more than rotating around that crankshaft. So you reduce friction by like 44%, so that does add a lot of efficiency also. They've been working on this for like 20 years, but the electronic control systems that they've always had just wasn't enough to manage it. And with the ones they have now, in about 1.5 seconds, you can go from all the way from full efficiency mode at 14:1 compression ratio, all the way down to power mode at 8:1, and it goes anywhere in between based on how hard you're pushing the motor. So some benefits is a 27% increase in efficiency over the 3.7 liter V6 that's in the QX50. That's like the little crossover that they have that in now. And the 3.7 liter is like Infinity's like baby, like that's what they made basically all their money on in recent years with that T37 and stuff like that. That's like their performance model. That makes like 360-ish horsepower. This motor is only offered in the 4-cylinder with this technology right now, so that makes like 268 horsepower. So it's not comparable to that as far as horsepower goes, but efficiency is like way better. And every car manufacturer right now has that 2-liter turbo like engine that they will just put in anything. That's basically taken away all of your smaller 6-cylinders, and this is going to replace all that. This makes it to where you can get, I think it's a 20% increase in efficiency on those without having the low compression ratio. So AMG, Mercedes, makes the CLA class with the 2-liter turbo, and their compression ratio is like an 8.6:1, which is super low, which adds a lot of boost. They have a huge turbo in that, and doesn't give a lot of fuel efficiency. And all the other 2-liter turbos, like from Hyundai and like Honda and stuff, they all do, I think it's like an 11:1 ratio. So you get the efficiency, but you can't get the power out of it. You can't add a lot of turbo. If you add that kind of turbo power and a lot of boost to it, you'll auto ignite. So basically how it works is the higher compression ratio means you get that power without the fuel, so you can save a lot of fuel like that. And your lower compression ratio allows you to add the fuel and the turbo, and then you get your power. So this is like the just a GIF of what it is. So this is the one where you're getting your efficiency mode out of it, and you'll see it change in a second. But see that's the difference in the top. You get a 6 millimeter difference between your top dead center, and your intake stroke is the same no matter what. Like your stroke distance between the top dead center and bottom dead center of each of these strokes is the same. So your intake, you get the same amount of air. But whenever you're pushing it up, you get a tighter compression on the top in this power motor. So this is electronic actually. It turns this and all that. Okay. Any questions? Cool.